Dr. Eldridge needs to fill a prescription for 300 milliliters of a certain skin cream where the active ingredient has a 12% concentration. However, when she goes back to check her stock, she doesn't have any cream that has a 12% concentration. Instead, she has a weaker cream, which has an 8% concentration, and she has a stronger cream, which has a 20% concentration. How much of each cream should she mix to get 300 milliliters of cream with a 12% concentration? We need to start with our let statements. What should our let statements be? Since they're asking us to find how much of each cream should be mixed, we'll let the amount of the 8% cream be X, and we'll let the amount of 20% cream be Y. Next, we need to make a table to organize our information. What relationship will we use to set up the labels for our table? The relationship is solution times concentration equals ingredient. Great. Now on the left-hand side, we need to label the 3 rows. The 2 creams being mixed are the 8% cream and the 20% cream. And when we mix them together, we get a third cream that has a concentration of 12%. So here, these are our 3 different creams. Now that we've set up our table, it's time to fill everything in. We'll start with the solution for the 8% cream. How much of the 8% cream will she need to use? We aren't told exactly how much of each cream she needs to use. This is an unknown quantity, and because it's an unknown, we already gave it a label in our let statements. We said that it was X, so the amount of the 8% cream solution is X. Similarly, the amount of the 20% cream is going to be Y, and we are told in total for the 12% cream, we need 300 milliliters of it. So that's going to be 300 down there. Next, we need to fill in the concentrations, but remember, we need to fill them in as decimal numbers. So 8% as a decimal is going to be 0.08. What is 20% written out as a decimal number? We know we have to move the decimal point 2 places to the left, and when we do that, that gives us 0.20, or really, we can just put 0.2. That extra 0 is not necessary. And then for the 12% cream, when we write that as a decimal, it's going to be 0.12. Now for the last column, to find out the ingredient, we multiply the solution times the concentration. So for the first row, X times 0.08 is 0.08X. For the next one, Y times 0.2 is 0.2Y. And in the last one, 300 times 0.12 is going to be 36. Now that we've filled out everything inside the table, including the information for the mixture, we're ready to write our system of equations to model the situation. What equation will we get from the relationship in the first column? For the first column, we have X plus Y equals 300. That's because we don't know what X and Y are. We don't know how much 8% cream and how much 20% cream get mixed. But the mixture needs to be 300 milliliters in total. So whatever X and Y are, when we add them together, we get 300 in total. The other equation comes from the third column, and we're going to get it very similarly. We take the first 2 entries, 0.08x plus 0.2y, and when we add them together, we end up with 36. The reasoning here is that 0.08x, that's the amount of the active ingredient in the first cream, and 0.2y is the amount of the active ingredient in the second cream. And we don't know what these quantities are, but in total, they need to be 36 milliliters, which is 12% of the 300 milliliters in total. That's how much active ingredient there are in that 12% cream. So now we have our system of equations, and we can solve it to figure out the values of x and y. I'm going to solve this system of equations by substitution. Let's start by isolating x in the first equation. What do we get when we isolate x? To get x alone, we need to subtract y from both sides. When we subtract y on the left, we've got x all by itself. And then on the right, we've got 300 minus y. And once we have this, we can substitute this in. Whenever there's an x in the other equation, we can replace it with 300 minus y. So we've got 0.08 times 300 minus y. That's the substitution that we made, plus 0.2y equals 36. Now at this point, we've got one variable in the equation. There's only a y here, so we can solve for y. What should we do next? To solve for y, we're going to want to get rid of these parentheses, and we can do that by distributing the 0.08. Now 0.08 times 300 is going to be 24, and then minus 0.08y plus 0.2y equals 36. Now we can combine like terms on the left-hand side. We still have that 24 out front. And then what do we get when we take negative 0.08y and add 0.2y? When we combine these, we end up with 0.12y, and that's still equal to 36. Now if we subtract 24 from both sides, that gives us 0.12y equals 12. And if we divide both sides by 0.12, that gives us y equals 100. Now, we've just learned that y equals 100. What does that tell us about the original problem? Because y represented the amount of the 20% cream, we know that there's going to be 100 milliliters of that cream. Now we also need to find out how much of the 8% cream is going to be mixed. But remember, we wanted 300 milliliters in total. If 100 of that is from the 20% cream, that leaves 200 milliliters left over for the 8% cream. The other way you can see that is by taking y equals 100 and plugging it into this equation right here. X is going to be 300 minus y, which is 100, and 300 minus 100 is 200. So that's another way to get the value of x. And so now we want to answer the question we were asked: how much of each cream should be mixed to get 300 milliliters of cream with a 12% concentration? So Dr. Eldridge should mix 200 milliliters of that 8% cream and 100 milliliters of the 20% cream. And that will give her 300 milliliters of a 12% cream, which is exactly what the patient needs.